A warm welcome to all the viewers. Friends, in this video, I am going to discuss about sensory evaluation tools, just about right and hedonic scale, both of them, and how to use them together to analyze, to assess the attributes and the likeliness of your products when you are doing new product development in food science or food technology domain. So I'm going to show you the technique how to analyze this thing and how to infer the results using a free software that is Jamovi. So no longer you need to do the calculations in Excel, wherein Jamovi can easily give you the penalty analysis results along with the significant level values, which will help you to optimize the recipe of your product which you are developing. So first we need to go into certain basics and fundamentals of both of these techniques so that we understand how to execute them. JAR standing for just about right. It has these 5 levels of rating, wherein 1 stands for much too little, 2 for too little, 3 for just about right, that's the middle point, 4 is too much, and 5 is much too much. It is a sensory evaluation tool used to measure the intensity of a particular attribute of a product, like its sweetness, saltiness, texture, flavor, aroma, etc. And penalty analysis, which is a feature of JAR analysis, is done by splitting the data into 3 groups for every trait. Those who choose the options 1 and 2, 1 and 2, those who choose the option 3, and those who choose the option 4 and 5. So we have 3 levels of the analysis in penalty analysis. What is hedonic scale? It is a sensory evaluation tool used to measure the degree of pleasure or liking of a product or service. And the scale usually consists of 9 levels ranging from 1 to 9, where 1 stands for extremely dislike and 9 stands for extremely like. The Hedonic scale is widely used for consumer acceptance tests. So now, when we will execute JAR technique for new product development, we are going to use it along with the Hedonic scale, which will help us to give a column of rating of the respondent upon the overall likeliness of the product, right? So this JAR analysis can be done on 2 levels, that is a single product analysis which tests one item or a recipe at a time for its attributes and tells us that which attributes needs to be optimized or improved. Then multiple product analysis help us to test 2 or more items at the same time. Now these 2 items could be the same items from different brands, or they could be different items wherein you have to test them against certain attributes. It helps to compare how different items score against each other and helps to choose the best recipe or see how a new product matches a rival brand. So these are the 2 levels of analysis. In this demonstration, I'll show you how to do single product analysis in Jamovi. Now, penalty score tells the loss or drop in liking associated with being on the low side or high side of the jar. So that means 1 or 2 or 3 and 4 on a 5-point rating scale of jar. JAR analysis identifies the attributes that need optimization, but it does not prescribe simultaneous change in all the identified attributes. So this point has to be noted because we cannot say that we have to change all the attributes together simultaneously when we do the JAR analysis. Actually, we have to look them at closely and investigate that which one has to be altered first in a newly developed recipe. So, for an instance, these 5 attributes like acidity, sweetness, artificial flavor, aftertaste, and color intensity. Now, these 5 attributes of an apple juice, which we will test through jar analysis technique. So in that data sheet, we have a data of 90 respondents, and it's a single level analysis wherein you are analyzing a single product on these five attributes. Now, if the evidence shows that it has the highest weighted penalty and both the directions are significant, the low direction and the high direction both are significant, then precisely calibrate towards jar. So this is what I'm going to show you, that how you obtain these results and how you interpret these results by data analysis in Jamovi software. Here I am in my Jamovi interface, and you need to load this module, that is jar module. How to get it? First, you can download Jamovi software, install it on your system. It's absolutely free to use software which can help you do several data analysis. Now, you can go to module and go to Jamovi library, and here you can type jar, and then you will see that this module is here. Since it is already installed on my system, it says installed. Otherwise, you need to install it. Once installed, then you are ready to do this just about right analysis. For that, we need the data set. So I'll use a sample data set available within Jamovi. I'll go to open, and then I'll go to data library, and in data library I have apple juice and purchase intention, two data sets provided by Jamovi. We'll use the apple juice data set. So this data set has been imported, and five attributes like color intensity, sweetness, artificial flavor, acidity and aftertaste. All these five attributes have been marked upon jar rating scale from 1 to 5. And then you have liking on hedonic scale from 1 to 9. So overall liking on hedonic scale, and this is a data of 90 respondents. The recommended sample size for doing this jar technique is near about 100. You can have 60 to 100. That is the prescribed one. And here we have 90 respondents in this case. Now, there shouldn't be any missing values in this case. So we have checked in for the missing values. And now we go for jar analysis. So just about right analysis, click over here and you take all the attributes, left click on color intensity, press the shift button and then left click on aftertaste. So I selected all five attributes, shift them to list of attributes. So what you see right here, you see the low frequency, that is 1 and 2 rating on jar scale for color intensity, sweetness, artificial flavor, acidity and aftertaste. So when you see over here, we had 90 respondents, and these are the people who have given a low rating to color intensity, 11 people. 20 have rated on the 3 level, that is just about right. 59 have rated on 4 and 5 level, that is high level. So this makes a total of 90. And then percentage wise, if you want to see this thing, this is shown over here. 12.2% of the respondents, 22.2% chose just about right, and 65.6 rated it high. That color intensity of your apple juice is high. So this is the way you can read this chart and get the descriptives of this chart. This is a descriptive analysis of this. Now what next? Here you have the attribute scale points, which we have selected to be 5. Since we are using a 5-point jar scale, it's we can also use a 7-point jar scale. And then we go to overall liking analysis. Here we have to put the continuous variable, that is liking, which was marked upon hedonic scale 1 to 9, which will tell us the overall liking or purchase intent. So I will shift this to this place, and instantly you see the penalty analysis results being generated. You see here weighted penalty analysis level low, and penalty analysis at high level. Below this, I have the jar plots option also, wherein I can see the attribute bar plot, the ternary plot with 3 axes, and I can also see the diagnostic plot. So let us click on show attribute bar plot, and we'll have a bar plot, a beautiful bar plot, which will show us the percentage of customers criticizing these attributes. So this runs from 0 to 100. So the more wider area of red color means more people are criticizing that attribute, right? So in this case, you see the color intensity is being criticized by a large number of people. So that is why it is high. And then just about right, that is 3. This is green is depicting 3 choice on these attributes by the respondents. And choice 1 and 2, which is the low level of color intensity or sweetness or artificial flavor, acidity and aftertaste, is depicted by this blue color, right? Now let us see the ternary plot. You can put all these plots in your dissertation, in your project, in your thesis, so they can be easily copied and taken. So you just right click and you can copy from here and put it in your Word file. Easily you can do it. This ternary plot tells us it has 3 levels on this triangle, right? The 3 levels of too low, just about right, and too high. So I can see that my 5 attributes like sweetness, acidity, aftertaste, color intensity, and artificial flavor have been put over here, right? So what to do? I can increase the size like this. You see, I have extended it and the size has increased so that I can have a better view. So I see where are they located actually on this triangular plot, right? So I can see that most of them are lying towards the high side, artificial flavor being on the highest side, and color intensity, right? Acidity on a lower side. This is too low, this is too high, right? So this is the way you read the ternary plot of attributes. And then you have the show diagnostic plot. So in diagnostic plot, you have a plot like this wherein you see the mean drop of overall liking and the percentage of customers criticizing that attribute. So you see here, artificial flavor is on low side. So again, I can enlarge this thing, make it large so that it becomes clearly visible to me. And then I see mean drop. See, if artificial flavor is being rated low, then how much will be the mean drop? It will be close to this point which lies between 0 to 1. It is a little bit ahead of 0.5. If they are marking color intensity on low, then how much will be the mean drop for overall liking? That was marked on hedonic scale. So that is close to 0.2 something, right? If they mark sweetness on low level, so the percentage of customers who are criticizing, we can see from here, that is around 28%. And if they are marking it on low side, then the mean drop is near about 3. Acidity high. So now you see here, red plus sign denotes high and blue negative sign denotes low, right? So acidity rated at high level by what percentage of customers? You see here, this percentage around 38%, which you see over here, they criticize acidity and they mark it at high level, right? And these person mark it at low level, 44%, right? So what is the mean drop? So if they rate it high, then the mean drop would be around 3. If they rate it low, then the mean drop would be around 2.8 something. So this is just a depiction of the results which we got in the tabular form above, which you see over here, right? The exact values you can see in these tables, which I already showed to you, right? You have the exact values. So how to interpret them? Let us see one by one. So if I go to color intensity and I see the weighted penalty, it is 0.650. So is this significant or not? So we will see the p-value. So since it is greater than 0.05, which is the prescribed significance level of testing at 95% confidence interval, we say it is higher than 0.05 since it is 0.216, so it is insignificant. Same is being told to us by the t-value, which has to be greater than minus 1.96 or plus 1.96 range. Since this is falling within the range of plus minus 1.96, so it is insignificant, and same result is being shown to us by the p-value as well. Sweetness, it is significant as the p-value is less than 0.05. So if you relate this with the descriptives over here, so you see that 65.6% of the people rated color intensity as high. They perceived color intensity of the apple juice as high. And this color intensity through the weighted penalty analysis is insignificant. So that means this rating given by 65.6% people on high color intensity is insignificant. It does not mean a lot. So we don't have to change this thing. Let me see sweetness, which is significant. And in this case, 54.4% respondents rated sweetness as high. So, do we have to reduce the sweetness? So, when you look at it, when you have a glance on this weighted penalty analysis, you will feel like, yes, we have to reduce the sweetness because um, it is significant. The penalty analysis shows that it is significant, right? So, when it is significant, we feel that we should reduce it. But should we reduce it or not? Not right now. We will go to the next chart to see whether we should do it or not. So penalty analysis level low. So in this, what do we see? In level low, we see that what will be the change in the likeliness of the apple juice by the respondents. Basically, the drop in the likeliness when they are rating the attributes on the lower side, that is lower side of just about right, that is value 1 and 2. So what will be the drop in the likeliness? So in case of color intensity, if someone is rating color intensity on 1 and 2, which is the lower side of just about right, that is 3, in that case, the drop in likeliness will be 0.0864. So likeliness will drop, and whether this likeliness drop is significant or not, we see through the p value, p tucky. P tucky means the p value, the significance value has been adjusted for multiple comparisons over here. Since we have multiple tests being done together, so it is similar to Bonferroni adjustment, which we do, which is greater than 0.05. So it is insignificant. If it would have been less than 0.05, as in the case of sweetness, it is 0.001. You say it is significant, right? So what to do now? So this shows that mean drop in case of sweetness, the likeliness, the shift in the likeliness towards the lower side of likeliness, that is, people are not liking it. If sweetness attribute, they are rating it on a lower level, that is 1 and 2, then the drop in the likeliness will be 3.0769 units, right? Now, if you see over here, sweetness has the maximum drop over here, and it is significant also. Before interpreting this thing, let me see the high level also. So when I see the high level, it means when people rate sweetness at 4 or 5 on jar rating scale, drop in the likeliness is about 2.143 units, right? And it is significant. So what to do? Should I change the recipe and alter the attributes which are significant in this case? So, you see that seeing the weighted penalty analysis, we see that sweetness, artificial flavor, acidity, aftertaste, all four are significant. When we see at lower level, we see sweetness is significant, acidity is significant, aftertaste is significant. Then sweetness, artificial flavor, acidity, and aftertaste, four of them are significant in high level analysis of the penalty. In penalty analysis at high level operating. So, what should I do in this case? The question is What should I change in a recipe? Which attribute should I alter? And should I make it higher or lower? Let us take an example of one of the attributes, acidity in this case, which has the highest weighted penalty. So it is 2.773. That means 2.773 units of likeliness are affected by the rating given by the participants on the acidity attribute of the apple juice. So if we see the low level, it is 2.59, and at high level it is 2.99. So that is high. So that means the likeliness is much affected by the high level, and acidity marked upon 4 and 5 by the respondents has a higher impact upon the likeliness. So what we should do? Should we reduce the acidity? Should we reduce the acidity? That is the question right now. Okay. Before deciding that we should we reduce the acidity, we have to check that what is the mean score of raw data upon acidity. So I go to exploration, descriptives, and here I put liking in the variables and acidity in split by, right? So liking variable will be split by acidity, and I'll go to statistics, mean, median, frequency table, and I got the results on the right side, you see. So it tells me that acidity level 1, 2, 3, 4, 5. How many people have marked upon that? 18 on 1, 24 on 2, 14 on 3, 14 on 4, and 20 on 5. So next I see that there are no missing values on all the 5 levels. And then I see the mean, right? So what is the mean? At just about right. At just about right level, the mean is 6.29. So that means the liking score is 6.29 on a 1 to 9 hedonic scale. So on a 1 to 9 hedonic scale, this is on a favorable side, right? So since this is on a favorable side, next I will check the mean of acidity. So how to check the mean score of acidity for the overall data, right? So I'll just take this back and I'll take acidity over here, and I got the mean score. You see, you simply put acidity in the variables, don't split it this time, and I can see this across rows like this. So now I have the number of respondents 90 on acidity, mean is 2.93, right? So what do you get to infer from the mean of the raw acidity score? In this case, this is 2.93, which is close to 3. That means just about right in this jar analysis. So that means most of the people in your analysis consider that the acidity of your apple juice is quite right. Then what about this high level of acidity which is shown in by the penalty analysis? This shows us that only a few number of people consider that the acidity is high. That means you no longer require to adjust the recipe for its acidity. So that is how step by step you have to conduct, analyze and investigate the attributes and get to know that whether you want to alter them in the next recipe or not. Now, in case this acidity, the mean score got was 4, which is quite high. That means acidity is quite high if we see it on a jar rating scale. In that case, we will go with this penalty analysis results. We will believe in this and we will say that yes, many people consider acidity to be high, and that is what is being depicted to us through the penalty analysis as well. So we must reconstruct the recipe of apple juice by lowering the acidity level. So friends, this is the way you conduct jar analysis using the hedonic scale for overall likeliness of the product. And I have also told you that how you can develop a new product based upon this analysis. I hope the video was quite informative and useful for you, and you will definitely share it with your friends and faculty colleagues. See you next time with some more informative content. Till then, thanks a lot.